Okay. Whether on YouTube it's visible. Let's check this link.
Yes, sir, it is visible.
Whether I am audible. Whether my voice is coming. Okay, okay. So it's visible on YouTube. Can somebody tell me whether can you see this? Slide delay, but it's clear.
Yes, sir. Slide is visible on the YouTube video.
Okay, it's visible now. So if you have any problem there, you can let me know. Okay. So we have to solve one problem based on this backpropagation neural network. So the one problem is there. So let's write this particular problem. So the question is like this: using backpropagation network, find the new weights for the net shown in the figure. It is presented with the input pattern 0, 1. So this is input pattern is
So
given.
your voice is being repeated twice on Google Meet and the YouTube.
Oh yeah. Okay. Okay. So the problem is using backpropagation network, find the new weights for the net shown in figure. It is presented with the input pattern 0, 1. So input pattern is given 0, 1 and the target output is 1. Okay. So target output is given 1. Use a learning rate alpha is equal to 0.25. So alpha is given 0.25 and binary sigmoidal activation function is given. So alpha learning rate is given 0.25, then binary sigmoidal function activation function, okay, it's given, and then the input pattern given, which is what, 0, 1, and the target is 1. So in the diagram it will be more clear. So the diagram is like this. You please draw this particular diagram, and in this diagram if you see here, the output over here, that will be 1. Okay, that is the desired signal. If we see only one output neuron is there, and the target for this output neuron is what, 1. Then if we clearly see, since this is back propagation neural network, so I told you in this one hidden layer will be there, one middle layer is there. So this is the z1 and z2, one hidden layer is there. This x1 x2, this is the input layer, and y is what, output layer. So this is the output layer, then hidden layer, and then this input layer. So input pattern is given 0, 1. Okay, if you see in the question, input pattern is given 0, 1. So that is what it is shown over here. This is 0 and this is 1. It's not minus. This is 0 and this is 1. Then the hidden layer is there. So from this particular x1, this 0.6 is going. This is a 0.6 weight, and from x2 0.4 is there. So this is 0.4 weight. From x1 to this z2 minus 0.3 is there. From x1 to z2 minus 0.3, and from x2 to z1 minus 0.1 is there, minus 0.1. From 1 to z1, this is a bias. So we know that in a backpropagation network there will be bias. So one bias is there on this z1, which is connected by 0.3 weight, and one bias is there on z2, which is connected by 0.5 weight. So these two biases are there on z1 and z2. One is there with 0.3 weight, and on z2 0.5 weight. Then on this particular output neuron. This output neuron is connected from Z1, that is hidden layer, by 0.4 weight. So this is 0.4, and from Z2 it is connected to Y by 0.1 weight. So this is 0.1 weight, and on output neuron there is one hidden unit. So this hidden unit is connected by minus 0.2 weight. Okay, minus 0.2 weight. This is a bias, so it's a bias, and then from this particular thing we are getting the output. Now I told you during the description of back propagation neural network that it works in 3 phases. So the first phase will be the forward phase. Okay, so in the forward phase, feed forward phase, we will have to apply the inputs to the hidden layer. Then from the hidden layer the inputs will be applied to the output layer, and we will calculate the actual output. So whatever output we will be calculating, that will come as what? Actual output. And so that will complete the first phase, that is the feed forward phase. In this particular phase we will going to calculate the actual output, and that actual output will be compared with the target output which is given in the question. And this comes under supervised learning. So after that the second phase will be, what we will do, we will calculate the error, and then error will be propagated in the backward direction. So error will be calculated, then it will be propagated to Z1 and then the input layer. So the second phase is called as back propagation of the error. Okay, after calculation of the error we will propagate that error in the backward direction. And then the third phase will be, after propagating the error in the backward direction, then the next step will be to update the weights. So that is the weight updation phase. And this is how this back propagation neural network works in 3 different phases. First is feed forward phase, in which we will going to apply the inputs and we will go in the forward direction. We will try to calculate the actual output, then we will match that actual output with whatever output is coming with the target output. We will try to find out what error is there, and then we will calculate the error, and that error we will propagate in the backward direction. So that is called as what? The back propagation of the error, second phase. And then the third phase is what? To update the weights based on these errors. Okay, so if this figure, if you're drawn, let's move ahead and we'll try to solve this particular problem. So step by step we will going to solve this. So here if we see, the new weights are calculated based on the training algorithm. So there is one algorithm which we will discuss. Okay, and once we'll solve this particular problem, it will become much easier. So the initial weights which are given, that is 0.6 minus 0.1 and 0.3. So I told you that the notation which you are supposed to follow, this is V11, V21, okay, and VO1. V11, V21 and VO1 is given. So V11 is given 0.6, V21 is given minus 0.1, and VO1 is given 0.3. So if we see here in the diagram, I told you that the weights between input, okay, weights between input and the hidden layer, you must treat as what? V. Okay, so by the notation V. So if you see here 0.6, that is V11. V11 means what? V11 means what? This one, from x1 to z1. Okay, from x1 to z1 we will denote by V11. So the input, this subscript we will take, and the hidden layer unit we will take that particular subscript. So this we will notify this by what? V11. Similarly, so V11 is 0.6. Okay, we will first try to write the weights on this particular hidden layer. What are the different weights which are there? And then similarly we will also write the weights which are there on this particular inputs which are there on this Z2. So if you see here, the first one V11, V21 and VO1 is there, that is 0.6 minus 0.1 and 0.3. V21, why? Because on this Z1 this input is coming, okay, this bias is coming, and this x1 is coming. So there are total 3 inputs which are coming on this particular Z1. So we will going to write all these weights in the bracket, right? So the first one is V11, which is this one is coming from x1, so that is 0.6. Then the next one is from here it's coming, and this is minus 0.1, and one bias is there, that is what? 0.3. This bias is denoted by VO1. So So wherever it's a bias, you must denote by VO, and then whatever is the subscript of the next neuron. So this is 1, so we are saying VO, O1. For example, this bias will be denoted by what? VO2. Okay, so this bias is there on the Z2, so we will say VO2. So basically remember, we are having the notation that is V, and between hidden layer and output layer we will be notifying these weights by W. Okay, so we will use the W between hidden layer and the output layer, and we are using V. You can use any particular notation, absolutely there is no matter. The idea is what we have to finally calculate. Okay, so that formula should the steps should remain the same, otherwise you can notify by any letter, that's up to you. But why I am saying, so that it will be common to all. So you can use V between input and hidden, and W between hidden and the output layer. Okay, so now for the Z1 we are writing what different weights are coming. So from X1 coming, X2 coming, and this bias is coming. So that's why I have written 0.6, that is V11. V21 is what? Minus 0.1, and VO1 is 0.3. Now similarly for this Z2 we will going to write. So for this Z2 it will be what? First we will write from this X1. So from X1 it's coming what? Minus 0.3. So minus 0.3, minus 0.3, and then from Z2 it's coming 0.4. So V22 is 0.4. This is V12. V12 is minus 0.3, V22 0.4, and this VO2, that is what? 0.5. VO2 is what? 0.5. So now we will going to represent this also in the bracket. Okay, if you see here, so V11, V12, V22 and VO2, V12, V22 and VO2 is represented by minus 0.3, 0.4 and 0.5. And then we will try to represent what are the W1, W2 and WO, that is the weights between this hidden and the output layer. So W1 is nothing but this 0.4, W2 is 0.1, and WO, okay, that is a bias, is what? Minus 0.2. So the weights between hidden layer and the output layer we are representing by W. So this is W1 because it's coming from Z1, this is W2, it's coming from Z2, and this is WO, right? If there are two neurons, output neurons, if Y1 and Y2 is there, then you can represent this as WO1 and WO2. But here only Y is there, so you can write WO, which is what? Minus 0.2. So we can write this also in the bracket, W1, W2, WO, which is what? 0.4, 0.1 and minus 0.2. So basically we have to write all the weights first of all, so that we will have the data. So what I will do, I'll try to write just 1 minute. Okay, so first we will try to focus on this particular, okay, for Z1. So for Z1 we can write what different inputs are coming to this Z1. So from here it's coming bias, from X1 is coming, and from X2 is coming. So we will write, so from X1 we will denote this as what? V, and this is 1 and this is also 1. So we will say V11. The next is coming this one from 2. So we will say V21. We will say here V21. and from this particular bias it's coming, so we will say VO1. So this we will represent the weights, we will write. So V11 is what, 0.6, so I'll write that 0.6. V21 is what, V21 is minus zero point 0.1, so I'll write minus zero point 0.1, and this is VO1, okay, which is 0.3, so 0.3. So this completed my V11, V21 and VO1 on Z1. Similarly I'll write for this Z2. Okay, now I will focus on this Z2. So for Z2 I'll write, so what are the total net inputs which are coming from X1, it's coming from this, X2 is coming, sorry, from X1 is coming, this X2 is coming, and then this bias is coming. So I'll write here, so from X1 I will try to denote as what, V, this is 1 and this is 2, so V12, V12. Then from X2 V22, so this is V22, and from this bias, so I will say this as what, VO2, VO2, and this I will represent what, minus 0.3, minus 0.3, V22 zero point 0.4, so 0.4, and VO2, this bias, so this is what, 0.5. Okay, so now I noted down the data, that is the weights between the input layer and the hidden layer in terms of V. Now I will focus on this particular output neuron, and I will try to write the W weights. So for Y I will write here, so from Z1 this is coming on Y, so I will denote this as W1. From Z2 it is coming on Y, so this is W2, and from this bias it's coming, so I will say this as what, WO, and the weights are nothing but W1 is what, 0.4, 0.4, this is W2 zero point 0.1, and this bias which is there, that is minus 0.2. Okay, so please note all of you, so that because all these things we will require for solving the problem, because from here only we will try to solve it. So the best thing is, for solving the backpropagation neural network problem, directly attack from the diagram. Okay, so from whenever the diagram is given, just you can go from the forward direction. First, whatever hidden layer neurons are there, just write in this particular format all the weights, note down the data. For Z1, suppose there are 5 neurons are there, so Z1, Z2, Z3, Z4, Z5, for all the 5 neurons we note down all the weights. Then go for the output neuron, okay, and that depends how many output neurons are there, and based on that we write all the weights of W, and then after that you proceed with the steps. So let's go ahead. Okay, I'll have to minimize, check. Okay, yeah, so now we will proceed with this one. Yeah, okay, so after writing that, you also note down what is alpha given. So alpha given is what, that is 0.25, because that will come in the formula, that will come inside the formula.
So the stream is lagging in between.
Okay, it's lagging.
Yes, sir.
Whether my screen is visible? Okay. Whether my screen is visible, all of you? Okay. So I was explaining you. Okay, about this. Yeah. Now you must also note down. You must also note down this alpha. What is alpha is given? So alpha is given 0.25. Okay, 0.25. Now we have to calculate. So we have to calculate. We know that here Z1 is there, right? And here Z2 is there. So on Z1 3 inputs are coming, and on Z2 3 inputs are coming. So first of all we will try to find out what is the total net
Yes,
input
sir. Screen is visible, but there's dual audio.
okay. So on here Z1 and Z2 we will have to find out total net input at Z1 and total net input at Z. So total net input at Z1 we will try to calculate first. How we will see what is the formula for the calculating. So this is the formula. Okay, this is the formula.
Sir, are you saying something?
Yes.
I think you are on mute.
All of you do one thing. You can come on this Google Meet. I think it's not happening there on YouTube. So all of you let it be that is there. You can come over here so that you can hear from this Google Meet. Okay. Whether my screen is shared na, on Google Meet, all of you can see, right?
So
Yes,
should we
sir.
close the YouTube video?
You can come out from there. You can just see the Google Meet. I was checking whether it was happening or not. Anyway, so there will be little bit lagging will be there. Whether this screen is visible, all of you, I can go.
Yes.
Okay.
Yes, sir.
So here two hidden neurons are there, Z1 and Z2. First we will calculate total net input at this Z1, and then we will calculate total net input at Z2. So how this can be calculated? We will going to use this particular formula. F of x is equal to 1 upon 1 plus e raised to minus x. okay, because this is a binary sigmoidal activation function, so we will going to use this one. If this is a bipolar, then the formula will change. So keep in mind, this is what unipolar formula, right? So 1 upon 1 plus e raised to minus x, we will going to use this particular formula. Now given the sample x1 is x1 and x2, what is it's given? That it's given as x1 and x2 is given as what? 0 comma 1. Okay, x1 and x2 given as what? 0 comma 1, and the target is given as 1. Target is given as 1. So first let's try to find out what is z in 1. So here total net input at this particular neuron, total net input at this particular neuron, I will denote as what? Z in 1. Okay, so total net input at z1. Similarly at this particular neuron I will say z in 2. Z into total net input at z2. So z in 1 can be calculated by, so for example here x1 will be coming, will be there, okay, so that we will have to calculate. So what different weights are coming? One is coming, that is VO1 is coming, that is this is a bias, and this is 0.3. so 0.3 plus, because bias we will going to directly add, because this will be connected by weight 1, so 1 into 0.3 will be 0.3 only. Then the next weight which is coming, that is from x1, and that is what? 0.6, and but the first x1 input is what? 0, it's 0, so this will be what? 0 multiplied by 0.6 plus 1 multiplied by minus 0.1, because x2 is what? 1, x2 is 1, and it is connected by minus 0.1 volt, minus 0.1 weight, and this total will be what? 0.2. Total is what? 0.2. If you want to check it, we can check it. So if you see here, just see here, so this is z1. So we will take what? This if we want to calculate, let's calculate from here only. So if you want to calculate, okay, so here we can write this 0.3 plus, because 0.3 plus this 0.6 multiplied by what is the input is there? 0. So 0.6 multiplied by 0, yep, it should be 0.6. so this should be what? 0.6. and then the next one is what? Here x2 it's coming, so x2 input is what? 1, so this 1 multiplied by this weight minus 0.1. okay, so total net is what? 0.2. Similarly let's calculate z in 2. so z in 2 will be what? So z into, from x1 this is what? 0 multiplied by minus 0.3, so 0 multiplied by minus 0.3 plus this x2 is what? 1 multiplied by this 0.4, so 1 multiplied by 0.4, and then plus this bias is there, so bias is what? 0.5, bias is there 0.5. then try to add, so this will become 0, this is 0.4 plus 0.5, so total will be what? 0.9. so this will be total net input at z2, and this 0.2 is what? total net input z1. now once you got total net input z in 1 and z in 2, now it's our duty to calculate what is the net output of this z1 and the net output of this z2. so how we will going to calculate this? Here comes the activation function. Okay, activation function is given. Which function we will going to use? So we will going to use this particular function, 1 upon 1 plus e raised to minus x. so here total net input we will going to substitute at place of x, okay, this will be replaced by what? z in 1, okay, and for z in 2 also, and we will calculate the total net output of z1 and z2. clear? so the next step is what? After substituting inside this activation function, we have to find out what is the output of z1 and what is the output of z2. so let's try to find out that. Till here all of you understanding? If you have any doubt, please let me know. Okay, because this problem is difficult also, so I want that we will solve one problem properly. Okay, and then after that I can guide you with the second problem, so absolutely no issue. But if you are able to solve one problem properly, then it will become much easier. So till now, if you have any doubt, please let me know. Okay, so I told you that now we will calculate the output of Z1 hidden neuron and Z2. So how we will calculate? We will going to substitute the values of Z in 1 in the function. So here if we see what we are calculating, we are saying Z1 is equal to, so in 4, similarly Z2 is what, 0.7109 multiplied by 0.1. So the output is coming 0.09101. So after point you can take 4 till 4 values. Okay, after point, and then once you got this y in, you can substitute inside the function f of y in to calculate what, y. Okay, so to calculate y, so this we will substitute like this: 1 upon 1 plus e raised to minus y in is equal to 1 upon 1 plus e raised to minus y in is equal to 1 upon 1 plus e raised to minus 0.09109, right? And this is calculated as what, 0.5227, 0.5227. Okay, so the answer of this one is what, 0.5227. Now in backpropagation neural network, we will also require its derivative. Okay, we will also require its derivative, and since the function activation function is of the form of what, 1 upon 1 plus e raised to minus x, so the derivative of this one, okay, the derivative of this f of y in can be calculated as what, f of y in is what, y in is 1 upon 1 plus e raised to minus y in. So the derivative of this one is given as f dash of y in, f dash of y in is equal to f of y in into 1 minus f of y in, f of y in into 1 minus f of y in. So this is the formula for derivative of this kind of function. Okay, if we will treat this as what, f of y in, so the derivative of this one will be what, f dash of y in is equal to f of y in multiplied by 1 minus f of y in. So f of y in we have calculated, f of y in is what, 0.5227. so this in the bracket 1 minus 0.5227. So calculate this one, f dash of y in. So this is calculated as what, f dash of y in. So the value will be what, 0.2495. So we have calculated first f of y in, then we substituted inside the function, that is 1 upon 1 plus e raised to minus x, and we got y, right? So that is the total f of y in. This is what we got, f of y in, and after getting this we are also calculating f dash of y in. So the f dash of y in formula is very simple, it's f of y in 1 minus f of y in. Okay, So just after substituting the values, we got f dash of y in is what, 0.2495, f of y in and f of y in which we got, that is 0.5227, and this one is 0.2495. so in short, now we got all the values. Okay, and the values which we got over here, that is a y, this is the actual output. Okay, this is actual output. But if you see in the target, the target is given as 1. Okay, target is given as, so there is a clear cut error, right? It's clear cut error is there. So now first phase is over. The first phase is what, feed forward phase. So in the feed forward phase, we have applied the input, we calculated total input at z, that is the hidden neuron. Then the output of hidden neurons we have calculated, and after that output we have calculated the total net input at output neuron, and then the total net output of, total output of that particular output neuron. And we have also calculated the derivative of that one, because we will require in the formula. And second thing, now we are saying that the target is 1 and the actual output which we got, so there is a difference. So now that we are going for the second phase, that is calculation of error. So the calculation of error, let's see. So till here, if any point, if you are not understood, please ask me if you have any doubt. Okay, so now we will calculate. Okay, we will calculate what is the error, which because there is a difference between your actual output and what, the target output. Now if you see the diagram, the diagram is like this. Y is there, and from here we are getting the output, and here z1 is there, z2 is there, right? And there is one bias. Now since there is only one y neuron, so only one error we will going to calculate, that is delta 1. So here delta 1 is denoted as what, error, right? So this delta 1 we will calculate as what, so the delta 1 can be calculated as actual output, not actual output, the desired output minus actual output. So that will be calculated as error, right? So if you see here, this is the target output. Okay, it's a target output, or this is also called as what, desired output, right? So we can always get the error by subtracting the desired output minus the actual output. So the formula for this delta 1, that is error we are calculating over here, is what, delta 1 is equal to 1 minus 1 is what, the target, and 0.5227. so this 0.5227 is what, your actual output, multiplied by, in the formula, this is what, f dash of y. Okay, this is what, f dash of y, and this is what, f of y in, or actual output y. Okay, the formula is like this. Delta 1 is what, 1 minus f of y in into f dash of y. So we are calculating this delta 1. So delta 1 is calculated as what, 0.1191. Okay, 0.1191. Now due to this delta 1, there will be changes in the weights because error is there. So definitely there will be changes in this w1 and w2, right? So we will calculate that one also, what will be the change in w1 due to this delta 1, and what will be the change in w2 due to this particular delta 1. So this is how it's calculated. You can remember the formula. So delta w1, this means the change in w1 weights due to this delta 1. Okay, that is this error. The formula is very simple, very simple. You multiply that learning rate. Okay, and then which error which is coming, which is being propagated in the backward direction. So this delta 1 is only there, so I am multiplying by delta 1, and to which particular which particular neuron? It's what? Z1 input is coming to this Y, so I am multiplying with that Z1 output. Okay, the Z1 output which is coming to this Y, so I am multiplying by this Z1. Similarly, if I want to calculate delta W2, just see here, if I want to calculate delta W2, so delta W2 alpha will be there, then this delta 1 is there which we have calculated, and for which particular neuron? So for Z2 output is coming to this Y, so that will be affected, right? So Z2, this will be the formula. So from the diagram, even if you don't remember the formula, from the diagram you can easily make out what formula you can write. So no need to actually remember the formula. So after this formula you can just calculate. Okay, you can just calculate what values you will get. So if you see here, delta W1 is what? 0.25 into 0.1191 into 0.5498, so you will get 0.0164, that is delta W1. Similarly, W2, if you see here, W2 is what? Alpha delta 1 Z2, so 0.25, so delta W2 will be what? Alpha, that is 0.25 multiplied by delta 1 is what? 0.1191 multiplied by 0.7109, 0.7109, okay, 0.7109. So if you calculate, you will get 0.02117. So this is about W1, change in weights of W1 and change in weights of W2. Now you know that there is one bias also, and the bias formula will be very simple, because the input which is coming from the bias, that is 1 only. For example, here Z1 is coming, Z2 is coming, right? So here 1 only is there, so the formula will be straightforward, and the weight, change in weights of bias is represented by delta WO, where it will be what? Directly alpha into delta 1, because there is no input is coming, but that is 1, right? So alpha into delta 1, and if we calculate this one, this is what? 0.25 into 0.1191, 0.25 into 11, 0.1191. So you can calculate, and this will become what? 0.02978, 0.02978. Whether my voice is audible, whether all of you can hear.
Yes, sir.
Okay, uh, what I am telling you, you can just go on that YouTube and mute that YouTube, that's it. Okay, and why? Because I want that you should be connected over there, so that it will be counted for me. So you can just open in one of the browser and just mute that, the sound you can mute, and I'll be continuing over here. Okay, now this problem is very big, so up till now we have solved only half. Okay, so let's see how much we'll be able to solve this. So let's proceed till here. If you are having any doubt, please let me ask. We have done one phase, that is we have calculated the total actual output, and then after that we calculated delta 1, because there is only y1, so we calculated delta 1. Agar y2 rehta to we would have calculated delta 2 also. Okay, so what is the error from the y1? That is delta 1. What is the error from y2? That will be delta 2, like this. And then delta 1, now we are trying to propagate in the backward direction. So we found out what will be the effect of W1 and W2, because W1 and Z1 and Z2 are connected to this Y by W1 and W2. So that thing we calculated, and we also calculated what will be the change in W1 and W2 because of that delta 1. Now after all these things, now we will calculate what will be the total error which will going to propagate from z1 and z2 to the x1 and x2. Okay, so that thing we will going to do, and then after that, once we will calculate that one, then we will calculate what will be the effect of that error on v, I mean the weights of v. Okay, v weights is there between input and what, hidden layer. So what will be the effect of that v on the v weights? So we will going to calculate in short the delta v weights, that is the change in v weights between hidden layer and the input layer. So that task we will going to do, and then after that we will going to update the final weights. So let's proceed. Okay. Okay, so now delta w1, delta w2 and delta wo we have calculated. Now we will try to find out, compute the error portion delta j between input and the hidden. So if you see, there are how many hidden layers? There are two neurons, z1 and z2. Okay, z1 and z2. So since there are two, so we will calculate. See here, the direction is what? If you see carefully, the direction is what? This is y, right? From y, this delta 1 is coming, right? This is what? z1, and this is z2. Okay, here w2, w1, and now if you see here, this is x1, x2, right? And this will be v11, this will be v22. Similarly, this weights is going there, this is coming over here, and one bias is there, right? One bias is there. Now what we are trying to do is we are propagating this error in the backward direction. So from this output layer, now it will reach where? To this z1 and z2. Okay, it will reach where? At z1 and z2. So we will try to calculate what is total input which is coming at z1 now, and what is total input at coming at z2 now, because of that error. So here we will going to represent as what? Delta input 1. Okay, delta input 1 at this particular z1. Similarly, delta input 2 at z2. So here we calculated delta, right? Now we calculated after that change in w weights, and that delta will also propagate towards this particular backward direction towards hidden layer, right? So at this particular z1 we will say delta in 1, and at this particular neuron we will say delta in 2. Now delta in 1, how it will be calculated? So delta 1 is coming, right? Delta 1 is coming, and this weight is what? w1. This weight is what? w1. Similarly here delta 1 is coming, and this weight is what? w2. Okay, so the formula will be very simple. For z1, delta 1 is coming, multiplied by what is the weight? w1, right? So this will be what? Actually it's w11 or w1. Similarly here also we are having only one weight, that is w21, or you can say w2. So we will just simply multiply delta 1. Delta 1 is what? Delta 1 we had 1191 multiplied by this particular weight. So this weight is nothing but 0.4. Okay, 0.4. So its answer will be what? 0.040764. Similarly, delta into. So delta into means what? The delta which is coming in the backward direction, and the w2. What is that w2 weight? So multiply that, you will get 0.1191. This is delta 1 multiplied by 0.1. This is what? w2, and you will get 0.01191. So we have calculated the net input error at z1 and net input error at z2. Net input error at z1 is calculated by delta in 1, denoted by delta in 1, and net input error at z2 is denoted by what? Delta in 2. Okay, now after this After this we will have to calculate the output of this one. So let's calculate, because we have to update this v11 and v22, right, and all the weights. So to update the weights, we will have to calculate the output of this z1 and z2 from the backward direction. So let's calculate that one. Okay, so if you see here, delta 1, now what we will do, we will calculate the way we calculated at y. Similarly here also we will calculate the f dash of z in 1. Okay, so f dash of z1, we are having this particular thing, f of z in into 1 minus f of z in 1, and this will be calculated as what, 0.5498, 1 minus 0.5498, this is 0.2475, and delta 1. Now delta 1 we will calculate. So because of delta in 1, okay, that is the total net input at, so I'll again draw so that it will be clear to you. Just wait. So if you see here, this is what, z1, this is z2, and this is y, and this is x1, x2. So now we have calculated total net input here. So this is what, delta in 1, and at here delta in 2, now we will calculate delta 1. Okay, delta 1, so that will be output of this z1, and delta 2, output of this z2. Okay, delta 1 and delta 2. So delta 1 will be calculated as, output of z1 will be calculated as what, delta in 1 total multiplied by f dash of z. Already calculated that f dash of z in 1. Similarly delta 2 will be delta in 2 multiplied by f dash of z in 2. Okay, f dash of z in 2. So you can just substitute the values and you can get the values. So delta 1 will come out to, let's say, 0.2055, and delta 2 will come out to 0.00245. So we have calculated output of z1 and z2 as delta 1 and delta 2. Now the next task, since we have calculated this one, we will going to update the weights which are coming to this z1, all the weights which are coming to this z1, and all the weights which are coming to this z2. So the weights which are coming to z1 is from x1, from x2, and one bias is there. Similarly the weights which are coming to as z2, one is from x1, this x1, x2, and one bias is there. So the three weights which are coming to this z1 and three weights which are coming to this z2, all the changes in those weights we will now try to calculate, and the procedure will remain the same. Sorry, the procedure will remain the same. So how we will calculate? So if we see here, suppose I want to calculate the change in weights of this one, because this is x1 to z1, so this will be denoted as what, v11. So let's say, suppose I want to calculate delta v11. So to calculate this delta v1, the alpha will be there always. Okay, alpha will be there, alpha into what is the error, delta 1 is coming from this one. Okay, so delta 1, and what is the input, the input is going what, x1, so x1 we will write. Okay, similarly suppose I want to calculate from this x2, let's say x2, it's going on z1, so that means what, this is 2 1. Okay, so change in weights v21 will be calculated as what, alpha into, so at this particular, which is the error which is coming, right, from here obviously delta 1 will come, so delta 1 into, at this particular is not x2, it's what, x2, so x2, and let's say the weights, the bias which is there on this z1, so the change in weights of bias vo1 will be calculated as what, alpha will be there, and delta 1 will be is what, that is 1, right, so no need to write this one, alpha into delta 1, this will be the formula. Similarly Similarly on this Z2, okay, here it's Z2, this is Z2. So on this Z2 it's like this. On Z2 from X2 is coming, so this will be V22. From X1 is coming, so this will be V12, and there is one bias, okay, there is one bias, this is VO2. So this is VO2, one bias. It's like this. Now we suppose we want to calculate the change in weights of delta V12. So delta V12, how we will calculate? From here delta 2 will come, right? So alpha into delta 2 into this x1. Similarly, suppose I want to calculate the change in weights of this V22. So this will be delta V22 is equal to, now you can say, you can clearly see that from here delta 2 will come, so alpha into delta 2, and what is the input? This is x2, so multiplied by x2. Suppose I want to calculate this VO2, so change in VO2 will be, from here delta 2 will come, so alpha into delta 2 multiplied by 1, so no need to write that, you can calculate. So these are the value. If you see here, so from the diagram only you will have to just remember one or two formulas, and simply from the diagram you will have to apply the logic, and solving from the diagram is much easier. Okay, so if you see here, V11 is what? 0. V21 is what? 0.00295. V01 is 0.00295. V12 is what? 0. V22, so this is the answer, 0.00061. Then VO2 is what? 0.0061. So this is what we calculated, the change in weights between input and the hidden layer. Change in the weights between input and hidden layer. So change in the weights we have calculated, we have back propagated the error, and we also calculated change in weights. Now the final step is very simple. What would be the final step? Final step is what? To update the weights. Okay, to update all the weights. So to update the weights will be what? For example, suppose I want to update, let's say V11. So V11 new will be what? V11 old plus change in V11, right? Change in V11. So change in V11 we have calculated over here. V11 old, we know in the diagram it's given, we can add and wait V11 new. So this will be the formula, this will be general formula for any weight. Let's say suppose I want to calculate W new, so this will be what? W old plus change in W. Okay, change in W. So this will be the normal formula to calculate the weights between anything. Suppose for the bias you want to calculate, so bias will be what? The old bias plus change its bias, so that will become the new bias. Clear? So let's see that one. Okay, so if you see here, V11 new, V11 old plus delta V11, similarly V12 new, you have to calculate all the new weights. Okay, you have to calculate all the new weights. So you can easily calculate, since you have the values, you can easily calculate all the new weights. So that means what? You are updating the weights based on that change in the weights, okay, which we calculated depending on the error. And after this, so after this what you can do, complete one iteration. Okay, this will complete one iteration, and for the exam only this much is what? Enough, right, to solve up to till here. And if you really want to carry out further more iteration, then what you can do, you can simply do what? Right, so you can reduce the alpha. If you want, you can reduce the alpha by, let's say you can do alpha is equal to alpha by 4 or alpha by 2 you can do. So initially it was 0.25, then you can divide by 2, it will become more or less, and then you can proceed with the next cycle. So you can take the new alpha value and you can proceed with the next iteration. So normally till if there is no error, we can proceed and or till whatever is the learning rate is specified, or if the number of iteration is matched. Suppose if from the start only it's mentioned that 100 iteration, so we're going to stop at that particular 100 iteration, right? Or if the desired values we are getting, then we will going to stop at that particular iteration. Not for the solving purpose, but for the coding purpose I am telling. In the code we can specify those things, and there our algorithm will stop, and then we can, we can have the final value. So but for the exam point of view, if it will come in the exam, you can show for the one iteration, and then you can stop after calculating these final weights. So this is what the back propagation till here. So if you have any doubt, please ask me. Also I will upload this video again, so you can watch it again. And one more problem is there, so two problems are there this on this back propagation. That problem also I will solve. And after this, after solving this, we have covered entire thing of the back propagation, right? Now whatever steps we did, those steps we will have to write in terms of algorithm. And suppose in the exam it is asked draw flow chart, so we will have to draw the flow charts of all those steps which we followed. Now it will become much simpler for we to draw the flow chart, because we now know the steps. But before that I want all of you to practice it, so that you will remember after this what will come, then after that which step will come, so that for drawing the flowchart will become much more easier, right? So if you anybody, if you have any doubt, please ask me anywhere. If you not understood, Mandar, are you there?
Ah, sir. Yes, sir. Yes, sir.
Okay, just mark the attendance of all. And the second problem, I don't think there is a point to start, because it will not be completed. So we'll see in the next lecture, or what I can do,
Okay, sir.
I can make the video and I can upload of that one. And then probably in the next lecture we can move ahead with the further topics. So just mark and then we can terminate.
Okay, sir. Sir, is there any of
Yeah,
holiday,
I didn't get what you are telling.
Diwali holiday?
Okay, so regarding the Diwali,
Is there any notice out for Diwali holiday?
for Diwali holiday we got circular from the university that from 12 to 18 there will be holiday. But from the college still we have not got, but I think there will be holiday. Okay.
Okay, sir.
Hmm. And before this Diwali vacation, we will give you all the question bank again, the same pattern, right? So for my subject I will give the question bank, and then the same thing will be there, right? For every subject you will get the question bank, so you can prepare in the Diwali. And for you people, BE people, I will suggest that, yeah Ashwin, I will suggest that you can,
So will the test?
yes Ashwin.
Yes, sir. Please continue.
So what I am telling you that in the
So will the test continue?
go ahead
Sorry, sir. I
Ashwin,
think there is a delay.
go
Sir,
Ashwin.
what I was meaning to ask, will the test be conducted in the same way, uh, like previously?
Regarding IIT, I mean internet test 2 you are asking, or final exam?
IIT too,
I,
because our MIS sir was saying that there will be some different format or something like that.
so till now I don't know about this. So most probably it will be objective type only, but let's see. Till now it's been told that it will be in the
All right, sir.
objective format only, because there is no point in keeping full no, I mean then we will have to do what we will have to tell you to write the answer, then you will take the peak and you will have to upload. So what is the guarantee that all of you are writing in front of us? Or I mean so many things will be there unnecessary. So let's see what they will say. So lagging, okay, so you will have to prepare the slides and you will have to present. So that will be treated as what, midterm presentation, and after that one more internal presentation will be there, that is before the external presentation, and that will be treated as what, for the term work. So even this will also will carry the marks, and date I am telling you that this will be on 5th or 6th. Why 5th or 6th? Because there will be different panel, and one industry person will come in that particular panel. So if the industry person is saying that he is available on the 6th, so we will schedule on the 6th December. But if he is agreeing on the 5th, the 5th will be on Friday. So if the 5th December is okay for him, then on the 5th December. So depending on that industry person, we will try to schedule your presentation, and will give you certain inputs, and then you can keep that particular thing also in your mind, and then there will be some time, period of time for the internal presentation. Till that you can just try to complete those things. So the notice of this particular I will circulate in 1 or 2 days after the meeting. So where any doubt should be terminate. So in the Diwali vacation you can just complete, okay, your project also, whatever is the remaining thing is there. Okay then, Mandar, done?
Yes, sir, done.
Okay then. Chalo, bye all of you.
Thank you, sir.
Thank you, sir.